All right, let's just jump right in. We are about to unpack a concept that honestly sounds like it's pulled straight from a science fiction movie, but it's not. It's a real, fundamental rule of our universe. Today, we're digging into the incredible mystery of time dilation. So let me start by asking you a question. And it sounds simple. Is time the same for everyone? I mean, does the second hand on your watch tick at the exact same speed as a clock on the other side of the planet? Or what about one that's zooming through space on a rocket? Everything in our gut, our intuition, tells us, of course it does. But the universe? Well, let's just say it has some very different ideas.
And that's really where we find the first crack in our whole understanding of time. Our day-to-day experience paints one picture, right? But physics shows us something way, way stranger, something far more flexible.
I mean, we all live our lives by this rule, don't we? A minute is a minute. It feels like the one thing you can truly count on. We plan our whole lives around it. Our meetings, our deadlines, our birthdays. It just feels so solid, so dependable, so absolute. But just for a second, what if that's not how it works at all? What if time isn't this big universal river that we're all floating down together? What if it's more like a whole network of individual streams, and each one is flowing at its very own pace? Well, this is where one of the greatest minds in history just strolls onto the scene. Let's talk about how Albert Einstein completely shattered our concept of a single, steady clock for the universe. And here it is, the core idea: time dilation. It's this absolutely wild concept that time can literally pass at different rates for different people. To put it simply, the faster you rocket through space, the slower you travel through time. And look, this isn't just some crazy theory. It's a direct outcome of Einstein's theory of relativity. He said it himself, plain as day. Moving clocks actually tick slower. But that just brings up another question, right? Why? Why on earth would the universe be built this way? Well, the answer has to do with something you can think of as the ultimate cosmic speed limit. So yeah, why can't time just be simple? Why does it have to have this weird, stretchy quality to it? It seems so complicated, but it's actually completely necessary to hold the very fabric of reality together. And here is that one unbreakable rule. The only true constant in our entire universe isn't time. It's the speed of light. It doesn't matter how fast you're going or where you are or who you are. If you measure the speed of light, you will always, always get the exact same number. And that number is it's staggering, around 300,000 kilometers every single second. It is the universe's ultimate speed limit. Nothing with mass can ever reach it, and its speed never, ever changes. No exceptions. So here's the kicker. If the speed of light must stay the same for everybody, then something else has to give. And that something else is space and time. They have to become flexible. They have to stretch and squeeze to make the math work. For a person moving incredibly fast, time itself has to slow down to make sure they still measure light at that one constant speed. Okay, I know this is all still pretty abstract stuff. So let's bring it down to earth with a classic thought experiment that makes this whole thing much easier to wrap your head around. The tale of two friends. So, picture this. We've got Ali, who stays right here on Earth, just living his life. But his friend, Sarah, she's an astronaut. And she gets into a super advanced spaceship and blasts off, traveling at, let's say, 99% of the speed of light. Now, from Ali's point of view back on Earth, if he could somehow watch Sarah, he would see her clock ticking incredibly slowly. He'd see her moving in slow motion. He would conclude, correctly, that she is aging less than him. But here's the twist. For Sarah, on her ship, everything feels completely normal. Her clock is ticking just fine. When she looks back at Earth, it's Ali's clock that seems to be speeding by like crazy. So, who's right? What happens when Sarah finally turns around and comes back home? Well, the physics of relativity is crystal clear on this. Sarah has genuinely physically aged less than Ali. He might have lived through 50 years on Earth, but for her, only 5 years have passed. She is now younger than her friend. Wild, right? Now, that sounds like a crazy paradox, but I promise you, it's not just some fun little brain teaser. This is real. This is a phenomenon that we have to deal with every single day, right here, right now. And I really want to hammer this point home. Time dilation isn't just a theory anymore. It is a proven, measurable, observable fact of our reality.
We don't just think it happens, we literally see it in action all the time. Just think about the GPS in your phone or your car. Those satellites orbiting high above us are moving really, really fast. Because of that, their internal clocks actually run a tiny bit slower than our clocks down here on the ground. And if the engineers didn't constantly correct for that tiny difference, your GPS would be off by miles within a single day. We also see it constantly in particle accelerators, where these tiny subatomic particles zipping around near the speed of light last way longer than they're supposed to. Why? Because from their perspective, time has practically slowed to a crawl. So what does all of this boil down to? It's this one crucial point. Time is relative. It's not absolute. Your personal experience of time passing is unique to you. It depends on how fast you're moving and where you are in the universe. And that brings us to one final, just absolutely mind-bending thought. If you could hop in a ship and travel across the Milky Way galaxy at nearly the speed of light, the journey for you might only take a few years. But when you return to Earth, you wouldn't find your friends or your family. You'd return to a world that is hundreds, maybe even thousands of years in the future. You would have, for all intents and purposes, traveled in time. Which leaves us with one last question to chew on. Knowing you would have to leave everyone and everything you've ever known behind, but you'd get to see a future you could never even imagine. If you could take that trip, would you do it? Something to think about. Thanks for joining me for this one.